For experiment 10 that you're going to do simultaneously with experiment 11, experiment 10 title emissions. The objectives of this experiment is to study the atomic line spectrum of hydrogen and analyze the emissions in the visible region. You're also going to look at the atomic line spectra of other elements. When an element is placed in a discharge tube under high voltage and low pressure, its atoms absorb energy and become excited. Now, the excited atoms emit light which when passed through a prism gives colored line that's resulting to what is called as the line spectra or line spectrum. So the line spectrum gives information on the atomic structure of the atoms, and each element has a unique line spectrum. So characteristic lines in the emissions spectra are used for the identification of elements. So the atomic emission spectrum of elements can be interpreted in terms of the quantum theory. Now, according to the quantum theory, electrons in atoms are located in orbitals having specific values. That is, atoms can only exist in certain energy states. So when the atoms absorb or emit energy, electrons can jump to higher or lower energy level. Thus, the energy of the atoms, the energy of electrons in the atom is quantized. So in going from a higher energy level to a lower energy level, the atom will emit electromagnetic radiation whose energy is equal to the difference in energy of the two levels. And this energy of light emitted or absorbed can be equated by the Planck constant, which is equals to E times Planck constant, okay, times frequency, or Planck constant times speed of light over wavelength. Okay, now Niels Bohr adapted these Planck constants to show that the energy of an electron in the nth level is equals to energy equals to Rydberg constant over n squared. Okay, so accordingly, in going from one energy state to another, the energy of the radiation absorbed or emitted can be represented by the following equation. So the energy is just equals to the final energy level minus the initial energy level. Okay? So if we're going to look at this so-called line spectra, so if we have the discharge tube here, you pass it through a slit and a prism, this is what you're going to have. So this is the line spectra of hydrogen, okay, helium, and the iron. So if you're going to look at it, this is very different from the continuous spectrum that you're going to observe here, like a rainbow color. Now usually this discharge tube, it emit a certain color depending on its element that it has. So for instance, helium would look like this, neon would look like this, argon, krypton, and xenon. So these are just the different discharge tube of the noble gases. So in this experiment, what you're going to do is you're going to use different discharge tube and you're going to determine the line spectra or line spectrum of each element. Now for this experiment, what you're going to do is you're going to use a device known as spectroscope. Okay, so it could be this form or this form, and if you're going to look at this device, spectroscope, or as an optical spectrometer, this is an instrument that is used to measure the properties of light over a specific portion of the electromagnetic spectrum, usually used in spectroscopic analysis to identify materials. So what you're going to do, you have a discharge tube here that contains a lamp for specific element, and you're going to focus this thing to the light source and determine what's the line spectra that will come out. So while this is on, this is a high voltage stop, so you don't need to, you're not going to touch it as much as possible. All you need to do is focus, okay, the device to the uh, light source, and you will see the line spectra of a given element. So this is the spectra that you're going to, the line spectra that you're going to observe when you use the spectroscope. Just as a guide to you here, this is the longer wavelength, and this portion is the shorter wavelength. Okay, so the most important thing that you will have here is this hydrogen that you're going to observe. Okay, and I also included here some other line spectra of other elements. For sodium, for instance, it has an intense line spectra here. For your lab report, what you're going to do is supply the information here. Okay, so we could say the red here, you put what, 656 nanometer here, and then determine the corresponding energy, okay, using EHB, or the one that we have like this, and then determine the transition, okay, energy level on how the red spectra or line spectra was observed. So I'm going to have a sample calculation, at least put this in the following slide, but you already done this using the I think the hydrogen also in our lecture part.